In this assessment, we're given a molecular formula, C7H6O, and an IR spectrum, and asked to tell where we're going to look in the NMR for signals that might verify what we think the structure is based on the IR. Well, a question like this should always start with calculating the index of hydrogen deficiency. And if we do that, what we notice for this one, we won't go through the calculation, but that index of hydrogen deficiency will be 5. So there are 5 degrees of unsaturation here. Now, having an index of hydrogen deficiency of 5 is always going to tell us, think about benzene, right? Benzene itself, if we draw the structure of benzene, benzene alone has 4 degrees of unsaturation, or an index of hydrogen deficiency of 4. 1, 2, 3 pi bonds and a ring. So when a molecule has an index of hydrogen deficiency of 4 or more, we should always be thinking about aromatic rings. Now, if we look at the IR spectrum, and I'm going to have a tough time pointing in the right spot, but you'll notice that we actually do see action in the aromatic region between 1600 and 2000, and we also have that diagnostic peak, those two peaks, at 1600 and 1450. So the IR spectrum confirms our idea that we probably have an aromatic ring. What else does it point out? Well, you'll notice that at around 1700, we have the sharp, intense band at 1700. That's going to suggest a carbonyl. Well, that makes sense in terms of our molecular formula that has an extra oxygen and our index of hydrogen deficiency that has an extra pi bond, right? So we've got 4 because of the aromatic ring. The other one is because of the carbon-oxygen double bond. The other thing you'll notice around 2700, we see those bands that represent the CH, suggesting that this might be an aldehyde. And we could go ahead and make a prediction about what the structure probably is for this molecule, even just based on the IR spectrum and the molecular formula. And you see how much information is contained in an IR spectrum in conjunction with the molecular formula for a small molecule like this. This molecule is probably benzaldehyde. Well, what would we look at in the NMR spectrum to discover that? Well, we would look for this hydrogen to be represented by a signal around 9. And then we would expect the 5 aromatic hydrogens, I'll draw those in. We would expect those to be around 7, between 6 and 7 parts per million. So ppm, not ppb. We would expect to see hydrogens between 6 and 7 parts per million for the aromatic hydrogens, and we would expect to see a signal around 9 for the aldehydic hydrogen.